I'll be going over a few of the week 3 StatLab problems in this video, and I'm going to be relying heavily on the week 3 spreadsheet, which is found in the week 3 lesson, to help me solve those problems. Each week has a spreadsheet and a video demonstration of how to use the spreadsheet at the bottom. The first question I'm going to look at is number 12. And we assume the body temperature of healthy adults is normally distributed, and then it gives us the mean and the standard deviation. So the first thing we're going to ask is what percentage of adults have a body temperature greater than a certain value. So in the week 3 spreadsheet, it lets us know, reminds us to put the values in the green cells, answers will be in the yellow cells. So here's where we want to enter our values for the mean and the standard deviation. For this distribution, I'm using these values that were listed up here in the directions for the mean and the standard deviation. And then for this particular problem, we're looking for the percentage of adults that have a body temperature greater than a certain amount. And so in the spreadsheet, there's 3 different situations we could look at. And the shaded in part in red here is illustrating those situations. This is being less than a certain amount, further to the left of the distribution. This is being greater than a certain amount, further to the right in the distribution. And this is the probability of being in between two different amounts. And so we're looking at 99.8 degrees. We would type that in here and understand the output here is the probability of getting a random healthy adult, that random healthy adult would have a temperature higher than 99.8 degrees Fahrenheit. And so Excel crunches all those numbers for us. We just need to understand the output here. This is the probability a random person has a temperature higher than this value. And it's all based off of the mean and the standard deviation of our distribution. So less than 98.28, I would want to find the probability of being less than a certain amount. So 98.28. And this is the probability that a randomly selected healthy adult out of the population has a temperature less than that amount. For part C here, the hospital is going to conduct tests on anybody who's not really close to the mean. So they're more than 1.5 standard deviations either above or below the mean. So what are those cutoff temperatures? You can use a calculator for this. I'm going to stick with Excel just because I have it open. But here, let me just get an empty cell. We want 1.5 of the standard deviation, either above or below. So if the mean is 99.07 and you were 1.5 times the standard deviation, so an entire 0.66 above the mean plus another half, you would be at a temperature of 100.06. And so that's the upper cutoff. And then our lower cutoff is, again, going from the mean and subtracting 1.5 times the standard deviation. And so that would be your lower cutoff for a temperature that is more than 1.5 standard deviations away from the mean. Number 13, we have a normal distribution again. It gives us the mean, the standard deviation, and we're looking for the probability or the percentage of people that are in between two values. So again, I'm going to use the week 3 spreadsheet here, type in the given mean for this distribution, type in the standard deviation for it, and then once I have those typed in, I can come use the in-between probability part. And so we're looking for the percentage of people that are in between two different values. And based off of the mean and the standard deviation, the answer pops up here in yellow. So this is the percentage of people between these two heights. It would also be the probability if you randomly selected one person that they would fall in between those two height values. 16 here, again, we have a normal distribution and we're given the mean. Where's that at? The mean and the standard deviation. So I'm going to start off in my spreadsheet by typing those in, the mean and the standard deviation from the particular problem. And Then we're going to see what type of question it's asking. Find the probability that a height for a randomly selected person, a weight for a randomly selected person is between these two weight values. So an in-between of 140 and 181, I want to use the in-between formula here. And this is the percentage of people that fall in between those weights, or the probability, if you randomly selected one person, that they're in between those weights. And I see my answer is off slightly there because I typed in the wrong mean. It was 148, not 140. Correcting that gives you the correct probability that we were looking for. So in part B, if 31 different pilots are randomly selected, find the probability that their mean weight is between those two cutoffs. So the average of the entire group of 31. We're going to use the central limit theorem to solve this, and when we look at groups of a certain size, the mean of those groups always follows a normal distribution. The mean of that distribution is the same as what the population mean was, but the standard deviation changes based off of the group size. And so we type in the population standard deviation, and you actually want to divide that by the square root of the sample size. And so if you just type those values in, the answer comes up for what our new standard deviation needs to be. We type that above here. So it's 4.615856. So if we're looking at groups of size 31, what their average for that group weight is, it has a distribution. This is what the mean of all those averages would be. And this is the standard deviation for groups of size 31, their mean. And so again, we're looking between those two weights. What's the likelihood a group of size 31 has an average between those two weights? And it's much higher percentage. And the reason it's gone up quite a bit is because with a group, the larger the group size, the really lightweight people, the really heavyweight people kind of all balance out, and you're going to get an average closer to the mean when you have larger and larger groups. And then part C is just about some application to this particular situation problem. When we're looking at a seat for a pilot, the individual matters more than a group average. We need it to work for each individual that is using it. And finally, looking at 17 here, this is kind of a quality control situation. We have candies. We know for the population, their mean weight, their standard deviation. And so that's what we're going to use for part A here. If one candy is selected at random, let's find the probability that it weighs more than a certain amount. So let's type in the mean for our population and the standard deviation for our population. And so what's the probability that one randomly selected candy weighs more than that certain value? And that's our answer. It shows up right there. That's if we just choose one candy at a time, what's the chances it has a weight? And we chose this weight, if you're reading through the explanation here, it's because we're printing on the label, this company's printing that the actual package weighs this certain amount. And so if you're advertising that to the consumer, you want to make sure you're really hitting that actual result so the consumer's not upset. And so to hit that result, if there's 449 candies for this problem that are in the package, each individual candy needs to have, and we get that by dividing the total weight by the 449, we get the weight that each individual candy would have to add up to 383.1. And so if we randomly just select one, it has a right around a 55% chance of meeting that weight. But in part B now, we're going to look at the entire group. If 449 candies, which is the amount in a package, if that's randomly selected, what's the probability that their mean weight actually meets this weight we're looking for? And this is the probability we really care about in quality control, because if their average weight out of the whole 449 is that, is that value, then the package will weigh as much as we're advertising it weighs. And so if we're looking at means out of groups of size 449, the average of those means is the same as the population mean was, but the standard deviation changes. It is the population standard deviation divided by the size of your sample. And so it's a much smaller standard deviation because with large groups, there's less variability. The large numbers, the small numbers cancel out. And so adjusting our distribution to have that new smaller standard deviation, the probability that our group of size 449 has an average, a mean, larger than the weight we need it to have is very high, which is good for our quality controls. And so with that large of a probability, it does seem that the candy company is providing consumers with accurate amounts that they are claiming on their label, because out of a random sample, over 99% of the packages they're selling would meet what they're printing on the package, over 99%.